So our next topic of discussion is called one-dimensional motion. Here's your instructions. What I need you to do. As you view this video, I need you to summarize the content of this lecture in your notebook. Write down any key vocabulary terms. We're going to start having some formulas and any main concepts or ideas that you think are important in this discussion. You are going to have a notes check after viewing this presentation. So what does this one-dimensional mean? Well, one dimension means it's only going in one direction, if you want to think about it that way. We have an X and a Y direction, and we've been talking about vectors, and we have looked at vectors that describe the motion of something like this. It is moving in X and Y together at the same time. That would be two-dimensional motion. Well, we're going to start describing how the motion happens. And we're going to start off with just one dimension at a time. So one-dimensional motion would be like moving just in the X direction. Or it could be just moving in the Y direction, but not both of them at the same time, at least not yet. We're going to do one-dimensional motion before we move on to motion in two dimensions at once. So we've been describing motion with this term displacement, which we know is how far are you from where your starting point and in what direction have you gone. We said somebody moves from point A to point B, and they're 5 kilometers from where they started, and they traveled northeast at an angle of 40 degrees. That tells us the where they wound up from where they started. What it doesn't tell us is how they got there. What was their trip like? How did they move from point A to point B? And that's the next part of our discussion. So displacement doesn't tell you anything about the trip. It could have been a 3-minute trip or 3 days to go those 5 kilometers. And there's a difference physically between traveling that trip in 3 minutes or in 3 days. And remember, physics is about explaining what's happening physically. And there is a difference here. So that's what we're going to head towards. In addition, maybe it took 2 hours and 2 minutes to move the trip, but you went the first mile in 2 minutes. Went really fast, but then the next mile took you 2 hours. Well, that's not the same motion throughout the entire trip. And one-dimensional motion seeks to describe what the motion was like. The first way that we commonly describe what a trip was like was, hey, how fast did you go? How long did it take you to make the trip? That is what we typically call speed. How fast were you going? We typically use numbers, say in our car, 35 miles per hour. That's how fast you were going while you were doing a trip. Could have been 5 meters per second. Could be 10 inches per day. Anything that describes how long it is taking you to move a certain distance is speed. How fast are you completing the trip? And speed is a scalar. It only tells you the number, but it doesn't tell you which direction. 35 miles per hour, that could be north, south, east, or west, or anything in between. So speed is the scalar quantity. Whereas velocity, here's our next big term. Velocity is how fast and in what direction are you going that speed. So velocity is a vector because it is a number quantity and a direction. It is both speed and direction. So we would describe speed with something like 35 miles per hour. The direction could be northeast. We could say it's 25 degrees northeast if you wanted to get more exact. We could also describe a speed as being 5 meters every second. I'm traveling a distance of 5 meters every second. That's the how fast part. Now the direction, we could describe it as up, down. We could say left or right. And typically when we do that, we're going to assign a value. And if we think about our XY coordinates, I like up to be my positive direction and down to be my negative. I like my left to be my negative direction and my right to be my positive. So once again, we're going to use positives and negatives with velocities, and the positive and negative tells us the direction. Now remember, if velocities are vectors, we know that vectors can be combined, like we did with our displacement. The end combination of all of our vectors that are added together is called a resultant. Here with displacement, it was the end result of where did I wind up from where I started. But consider velocity as a vector. Imagine I am walking forward with a velocity of positive 5 meters per second. But let's say there's a really, really strong wind blowing in my face that is blowing at a velocity of negative 5 meters per second. Notice I say negative because we're saying the wind is blowing that direction. Negative velocity because it's working in the negative direction. My positive velocity is going forward in a positive direction. The end result here is a velocity of 0 meters per second because they cancel each other out. Vectors add together. Now, on the other hand, if I was walking this way with a speed of 5 meters per second and the wind was behind me at 5 meters per second, my resulting velocity would be 10 meters per second in the positive direction. Remember that vectors can always be combined. They are always combined. They add together, and the end result is called a resultant. In this case, the resultant is a velocity, not a where or how far, a displacement. Now, to calculate velocity, you might recognize this formula here from middle school physical science. They typically call this the speed formula. You got speed is distance over time. Now that you're in physics, we can get a little bit more scientifically correct and say that this is actually a formula for calculating the average velocity. Now, what is it? What I mean by average velocity? There are two terms we're going to look at here. The instantaneous velocity and the average velocity. Instantaneous, instant. The instantaneous velocity is the right now velocity. At one moment in time, what is your velocity? And that might be 55 miles per hour due east. The average velocity is just what it says it is. It's on average what was your velocity. So imagine you look down the speedometer and you're going 55 miles per hour. And some of your speedometers even have a little kind of directional thing to tell you north, south, east, or west. That is the right now, that is the at that instant velocity. But the average velocity is the average of all of your velocities together. And it is calculated with this formula here. Velocity equals d, which we are more accurately going to call displacement now, not really distance anymore. And time is time. Well, why are we going to say displacement instead of distance? Because displacement is a vector quantity and it has a direction associated with it. So I run a stopwatch and my displacement is from here to here. Say that is a displacement in the positive 5 direction. And I'm running the stopwatch and it takes me 5 seconds to go those 5 meters. My displacement was I wound up 5 meters from where I started. My average velocity would have been 1 meter per second. But what if I went this direction? That would be a displacement in the negative direction. My number up here would now be negative. And let's say it took me 7 seconds to do it. Well, my displacement is -7 divided by 7. I'm going to get a velocity that is -1 meter per second. What does that mean? Well, that means I was moving in whatever direction I said was the negative direction. We're generally going to assume that this way is negative and this way is positive, although not always. As it turns out, average velocity is not really that helpful to us. We need to understand the concept. Consider this path of 0 to 4 meters. Let's say the first meter I did in a minute, but then the next meter took me an hour, this meter took me 5 minutes, and this meter took me 2 days. I could still do a velocity equals displacement over time, but we can just look at this and we get the idea that the average is going to be skewed. The average doesn't really tell me much about that point right there versus that point right there. So we're going to focus a lot more on what is the velocity at a particular instant in time rather than the average. This leads us to our discussion of acceleration. Acceleration, we know in everyday terms, means speeding up. You press the accelerator, you go faster. However, in a physics sense, we need to be very careful about what we call or how we define acceleration. The definition of acceleration is any change in velocity. And if we think about this trip right here, you can see we were having a distinct change. Our speed, our velocity from here to here was different than our velocity from here to here because the same meter took us longer to cover. Well, a change in velocity is what acceleration is. Typically, we think about acceleration as this. You're going faster. You press the gas in your car and you speed up, you accelerate. However, putting your foot on the brake is also an acceleration because you are changing your velocity. You are slowing down. You're covering less distance in the same amount of time. So speeding up and slowing down are both examples of acceleration. Acceleration is a vector. It works in a particular direction. If you are speeding up, the acceleration and the velocity have the same direction. If you are slowing down, velocity and acceleration are working opposite one another. They're vectors that are canceling each other out a little bit. So let's consider a car, and it is moving at a certain speed this direction. Pick a speed. We'll say the velocity here is 30 miles per hour, and I'll call it negative because if we're saying it's moving in the negative direction. So imagine this guy's got his cruise control set at 30 miles per hour, and he's moving this direction. So long as he doesn't hit the brake or the gas, there is no acceleration. That is what we call a constant velocity. To be constant or have constant velocity means you have no acceleration, or your acceleration is 0. However, consider this same car. Let's say this car once again has the cruise control set at 30 miles per hour. The cruise control is set, the car takes a path like this at a constant 30 miles per hour. Now that isn't describing a velocity, that's a speed. The question here, is there an acceleration? The answer is yes, because remember, velocity is both the speed and the direction. So think about this path. Even though the speed stayed at 30, when the car goes around a corner, around a curve, it is changing direction. Well, changing direction is changing velocity, and acceleration is defined as any change in velocity. So, therefore, an acceleration can be speeding up, slowing down, or changing direction. Once again, acceleration can be speeding up, slowing down, or changing direction. Let's talk about how we calculate acceleration. Now, acceleration is going to be represented by the letter A. V is velocity, T stands for time. But now we've got two different velocities, because remember, for there to be an acceleration, there is a change in a velocity. So you got more than one. Now we're going to use this convention here. The VF, the F stands for final or ending. The I stands for initial or starting. Now this quantity can be both positive and or negative. Let's look at a negative acceleration. How do you get a negative out of this? Well, time is never negative. So in order for this to be a negative quantity, the final velocity has to be less than the initial. So in the end, you're going slower than when you started. We commonly would say that as slowing down, because in the end, you're slower than when you started, so you have had a negative acceleration, you're slowing down. A positive acceleration, we would commonly say as speeding up, because this number is now bigger than this number. So you're going faster at the end than you did at the start to make this a positive quantity. So a positive acceleration means that you are speeding up. What we are studying here is called kinematics. Kinematics is the study of the motion of an object without regards to the force that is causing that motion. So that's all we're trying to do here. We're trying to figure out, well, how much is it speeding up or slowing down? We'll worry about the cause and effect later, but there are some kinematic equations that we're going to reference. The first, I'm going to rewrite it here. A equals VF minus VI over T. We are going to take this and rearrange this to solve for whatever we want. You might see this equation written this way. Those two are the same. All we've done is we've rearranged this to get the VF by itself. Like that's what we want to solve for. And we isolate that variable and equate it to all the other variables in the equation. This is what you're going to have to do very commonly. You're going to have to figure out, what am I solving for? Rearrange these kinematic equations to solve for whatever we want to know about the motion of an object. Now, these are all things that are moving. They're going places. The distance or the displacement of an object is certainly affected by its velocity and acceleration. We can figure out how far something has gone if we take its initial and final velocity together, divide it by 2, which would give us an average velocity times the time. This is one of the ways we can figure out, based on the velocity, how far something has gone. There's another equation that allows us to solve for the distance traveled. The difference between these, you notice this one has an acceleration in there. This here is for unaccelerated motion or uniform accelerated motion. This one here has no acceleration in the equation. This one, no acceleration. This one, acceleration. So depending upon what we're given about an object, we might use this formula or this formula to solve for the distance traveled. Finally, there's this relationship. The final velocity squared, the initial velocity squared, plus 2 times the acceleration times the distance. So what we're going to start doing is practicing with these and solving for the unknown variable, and then we're going to test some of these experimentally. At this time, the presentation is done, and you're going to have a notes check to see if you have all of the key concepts and ideas that you were supposed to out of this presentation.